we are presenting decomposition and reasoning for video individual counting. Pedestrian counting is a fundamental tool for understanding cloud patterns and cloud flow analysis. Existing works mainly focused on the image level counting. Single image cloud counting estimates the cloud number in the image level, which reflects the degree of cloudiness at a certain time point. Cross-line cloud counting techniques estimate the pedestrians in a period of time by setting a proper feature line, which could reflect the cloudiness and the total cloud number in the video to some extent. This work targets a similar but different work, video individual counting, where pedestrians in a whole video with different identities only be counted once. Multi-object tracking methods can be a feasible solution for VIC. However, the accuracy and the efficiency would be inferior for two reasons. For accuracy, the object association in MOT depends on the detection results and extremely suffers from the ID switch, which leads to the overcounting. For efficiency, most MOT operates on each frame, which is time-consuming and not necessary for the counting task. Cross-line counting methods only count the pedestrians passing the line or would miss the cloud staying in the video or disjointing with the line. Besides, the line selection is flexible and needs to vary in different scenes. As the first equation formulated, we here propose to solve the VIC from a new perspective, which decomposes all pedestrians into the initial pedestrians who existed in the first frame and the new pedestrians with separate identities in each following frame. As there are high similarities in adjacent frames, we relax it with a time step, making this method more efficient and less computation. This figure outlines the DR.VIC architecture, which is composed of three components. Given a pair of images, the backbone first extracts their multi-scale future representation, ft and ft plus tau, with two sets of head-center proposals for frame it and it plus tau. We extract two sets of head descriptors for subsequent pedestrian reasoning. As shown in this figure, given subjects with their descriptors in set x and set y, our goal is to divide them into three categories. 1. Mixed instance pairs, the common set of x and y. 2. Unmatched outflow instances, the rest subset of x. 3. Unmatched inflow instances, namely I, the rest subset of y. Thus, the size of set I is the number of inflow that we want to get, namely the inflow pedestrian number. To solve the problem, we first define augmented counter-weighted OT problems to reason the pedestrian flow. Where P is a transportation matrix, as depicted in this figure, its element Pij represents the probability of the ith pedestrian in the preceding frame is associated with the jth people in the current frame. The row vector Pm plus 1 is defined to collect the inflow pedestrian. C is the coarse matrix, while Cmn is the inner product of set x and y, which minus their similarity. Cm1 and C1n are two augmented beings in this paper. They are filled with a learnable parameter. UAB is a discrete measure with respect to probability vectors A and B. Finally, DR.VIC uses a fast-speed sinkhorn algorithm to solve P. As the whole process is totally differentiable, DR.VIC is an end-to-end trainable framework. We here use two video benchmarks, Cloud Height and Sense Cloud, to evaluate DR.VIC. This table details their scale. As for evaluation metrics, we use standard MS in the IMAE on the video level. And we also define a weighted relative absolute errors to measure the performance, which give an intuitive result even the videos are with different lengths and pedestrian numbers. Overall, DR.VIC outperforms all tracking-based methods and the cross-line method with an obvious improvement. Especially the errors are much smaller in Sense Cloud because it's faster. The MRAE 12.7% is relatively low, making it possible to be deployed in the future. DR.VIC makes precious reasoning in sparse scenarios as shown in the examples. However, there are also some field cases in a more complicated scene, and there are still a lot of aspects can be improved in the future.